what if we aren't Earth's first advanced civilization?
Mhm.
Now, that sounds like something straight out of science fiction.
It really does. But it's a question scientists are genuinely considering when they look at the sheer timescales involved in our planet's past.
Yeah, exactly. So today, we're doing a deep dive into this concept of deep time. We're talking about these, well, almost incomprehensible stretches of Earth's history.
Mm-hmm.
And our mission really is to unpack how thinking on this colossal scale changes how we see potential past civilizations, how it might inform what we do in the future, and, maybe even challenge our own place in the universe.
And this deep dive, it's really not just about abstract theories floating around. We'll be looking at the scientific challenges. Like, how would you even find evidence of civilizations that might have existed, long, long before us?
Right.
And then there are the philosophical implications of thinking that far ahead or that far back. We'll even touch on how this huge timescale can, maybe surprisingly, offer a bit of solace.
Call us interested.
Yeah, it's about grounding our very human, sometimes fleeting experiences in this much bigger geological picture, seeing how we connect to billions of years of planetary history.
Okay, so let's try and grasp this scale first.
Yeah.
Deep time. There's this great analogy from John McSee. He says, imagine Earth's entire history, all 4.55 billion years,
Mm-hmm.
stretching from the tip of your nose to the tip of your outstretched middle fingernail.
Okay, got it.
Now, take a nail file. Just one quick swipe across the tip of that nail.
Yeah.
That single swipe, it erases all of recorded human history.
Wow. Okay, that puts it in perspective. It's humbling, isn't it?
It really is.
And, people were wrestling with this idea, well, long before modern geology came along. Back in the 11th century, you had thinkers like Shen Kuo in China and Ibn Sina in Persia. They were already theorizing about huge geological changes and vast timescale.
How so?
Well, Shen Kuo, for example, he noted finding fossilized bamboo way up in the mountains in a dry northern area where bamboo definitely didn't grow anymore. So he suggested, that climates must have shifted dramatically over huge periods.
That's incredible for the 11th century.
It is. And then in Europe, things really took off with James Hutton in the 18th century. He looked at this place in Scotland, Sycamore Point.
Ah, yes, the unconformity.
Exactly. Layers of rock tilted almost vertically with horizontal layers right on top of them. It was clear evidence of, well, unimaginable amounts of geological time and processes, upheaval, erosion, more deposition.
Just cycles upon cycles.
Precisely. But Hutton's own book on this, Theory of the Earth from 1795, well, he himself apparently called it unreadable.
Huh. Maybe a bit dense for the average reader back then.
Possibly, or perhaps just very technical. He really needed someone to translate it for a wider audience.
And that's where John Playfair came in, right? The popularizer.
Exactly. Playfair wrote illustrations of the Huttonian theory of the Earth in 1802. He simplified Hutton's ideas, made them accessible, and that really laid the groundwork.
Groundwork for Darwin, eventually.
In a way, yes, because Playfair's work paved the way for Charles Lyell and his massive work, Principles of Geology, from the 1830s. And that book famously went with Darwin on the Beagle voyage.
Right, it gave Darwin the timescale he needed for evolution to make sense.
It donated the time frame, as one source puts it. Lyell established the geological column, gave us terms like Devonian, Cambrian.
He kind of mapped it out.
He did. He domesticated time, made it something we could study and categorize. But even with the labels, the sheer scale, it still inspires awe. Playfair himself, standing at Sycamore Point, wrote something like, "The mind seemed to grow giddy, looking so far into the abyss of time."
You can feel that sense of vertigo even now, just thinking about it. So, okay, we've got this vast expanse of time, billions of years, which naturally leads to that really provocative question. Were we the first? Is our civilization the first advanced one on Earth?
And that's the core of the Silurian hypothesis, proposed by Adam Frank and Gavin Schmidt.
Silurian. Like the Silurians in Doctor Who,
Yeah.
the intelligent reptiles.
Exactly. That's where the name comes from. It's a nod to that idea.
And it wasn't just Doctor Who, right? Didn't a sci-fi novel explore this too?
Yes, James Hogan's Inherit the Stars back in 1977, it imagined finding evidence of unknown technology on the moon from Earth's past.
Okay, so fun thought experiment, but what are the actual scientific challenges here? How hard would it be to find evidence?
Immensely hard. I mean, look at us, Homo sapiens. Clear evidence for our species only goes back into the Quaternary period. That's the last, 2.6 million years?
Oh, it just sounds like a lot, but in geological terms.
It's nothing. Even our earlier bipedal relatives, like Australopithecus, who left those Laetoli footprints, that was about 3.7 million years ago. And consider this. The oldest large intact land surface we can study on Earth today is the Negev Desert, and it's only about 1.8 million years old.
So the planet basically recycles its surface.
Constantly. Erosion, sediments burying things, plate tectonics pulling crust down and melting it. Ancient landscapes just don't stick around easily.
Okay, so finding actual ruins or objects seems unlikely.
Very unlikely, especially if you're talking about something older than a few million years. Complex life has been on land for maybe 400 million years, but agriculture, that's only about 12,000 years old. Industrial tech, maybe 300 years. These are tiny, tiny fractions of Earth's history.
Right.
And fossilization itself is rare, especially in places like jungles where things decay fast. Think about dinosaurs. They ruled for 165 million years, and we only have a few thousand decent fossil skeletons.
So the chances of finding, say, a million-year-old smartphone?
Slight laugh. Essentially zero. Even for something less complex, like the Antikythera mechanism from ancient Greece, that amazing astronomical calculator.
Yeah.
It was unique for centuries. It wasn't mass-produced. So finding any specific artifact older than maybe the Quaternary is incredibly improbable.
Okay, so direct evidence, like finding an ancient city, is probably out. What about indirect traces? What might last?
Now that's where it gets interesting. The paper talks about technosignatures, things left behind that aren't objects themselves, but chemical or geological markers.
Like what? Pollution.
Exactly. Things like certain plastics or specific long-chain synthetic organic molecules might persist in ocean sediments for millions of years.
Really? Plastics?
Potentially, yes. Or think about other large-scale changes. One example mentioned is the granite used for railway beds in Florida.
Well?
That granite was imported from Georgia. If Florida sinks and resurfaces, geologically speaking, future geologists might find this weird igneous anomaly granite where it shouldn't be. The steel rails and wooden ties would be long gone, but the rock signature could remain.
Huh. Never thought of that.
Or even things like metal bolts rusting away but leaving strange threaded patterns imprinted in the rock.
Like fossilized screw threads.
Kind of, yeah. Or layers of petroleum-based asphalt from roads, or maybe even rubber particles from tires building up in sedimentary layers.
And what about ice cores?
Ice cores could be useful, but probably only for civilizations less than, say, 1 million years old. They could potentially show spikes in industrial pollutants trapped year by year.
So we're looking for subtle chemical or geological fingerprints, basically.
That's the idea. Things that fundamentally alter the planet's chemistry or geology in a way that stands out from natural processes.
Given how much our planet churns, what about looking off Earth? Could evidence survive better elsewhere?
That's a really good point. The moon, for instance. No plate tectonics, no significant erosion. If a previous civilization had space travel, leaving equipment or structures on the moon, well, that might last much, much longer.
Or satellites?
Dead satellites in very high stable orbits could also persist for potentially millions of years, much longer than anything on Earth's surface, which eventually gets subducted or eroded away.
So we might find traces on the moon or in orbit.
It's a possibility. It even raises this weird scenario. What if we find something artificial out there and we assume it's from aliens, when actually it's a relic from Earth's own deep past?
Exactly. It's another layer of complexity. Makes you scratch your head, doesn't it?
Okay, so there are ways evidence might survive. But what are the big arguments against the Silurian hypothesis? Why do most scientists think we probably are the first?
Well, the big one is the evolutionary record. If an intelligent species evolved to the point of industrialization, you'd expect to see a long evolutionary history leading up to it in the fossil record.
And we don't see anything like that before hominids.
Nope. No signs of creatures developing the kind of brains and, say, hands needed for complex tool use way back in the Devonian or Cretaceous. Another major point is the environmental impact. An industrial civilization leaves a massive footprint. We're seeing that right now.
Climate change, pollution. Right. Changes in atmospheric composition, ocean chemistry, sea levels. The paper points out that, for instance, during the Cretaceous period, CO2 levels were naturally very high, maybe up to 1,000 parts per million. Sea levels were over 200 feet higher.
Wow.
If a prior civilization caused such a massive shift through industry, the geological signal should be pretty clear. But the signals we see from past warm periods seem consistent with natural geological cycles, not artificial causes.
So no obvious smoking gun in the geological record.
Not really. And there's simply no fossil evidence of anything resembling an earlier technological species. Plus, as we said, things like agriculture, which seem necessary for large, complex societies, only appeared relatively recently, so the odds seem stacked against it.
Okay, so it's a fascinating idea, but the evidence, or lack thereof, points towards us being the first so far. This whole discussion about immense timescales and how hard it is to leave a mark, it really makes you think about our own legacy, doesn't it?
It absolutely does.
Which kind of brings us to this other fascinating topic, the clock of the long nail. This massive clock being built to run for 10,000 years.
Yes, a really ambitious project. It was conceived by Danny Hillis, an inventor known for parallel computing, back in 1986. It's part of the Long Now Foundation, which was set up in San Francisco during the tech boom of the 90s.
And their mission is?
Their stated mission is to foster responsibility in the framework of the next 10,000 years.
10,000 years, that's a long time horizon.
It is, and it's funded significantly by Silicon Valley money, perhaps most famously with a large $42 million donation from Jeff Bezos.
So Hillis called it the world's slowest computer. What was the point? Why build something like this?
His intention was for it to be a symbol, a monument to long-term thinking, kind of a counter-narrative to the incredibly fast pace of market cycles and technological acceleration that he saw all around him, especially in tech.
Like a physical reminder to slow down and think bigger.
Essentially, yes. A corrective, almost, to the obsession with faster and faster processing speeds. He wanted to embody patience and long-term perspective.
How has it been received? I imagine a project like that draws some strong opinions.
Oh, definitely. Early on, back in the 90s, you saw praise in places like Wired magazine. They called it an admirable objective, noted the impressive engineering. But more recently, especially since construction moved to Texas on Bezos' land, it's become, as one source puts it, a lightning rod for criticism.
What kind of criticism?
All sorts. Some see it as a distraction from the short-term practices of companies like Amazon. Others call it luxury art for billionaires. There have been critiques about it embodying a sort of crisis of masculinity or being a Gilded Age distraction, harking back to when robber barons built grand monuments amidst social inequality.
So, quite a bit of backlash. How does the long now community itself view the clock, especially in light of these criticisms?
Well, for people involved in the foundation, they often see the clock as more than just its physical presence. They talk about it being like a piece of theater or a mirror, something that reflects back the values and concerns of each generation that encounters it.
So the debate itself is part of the point.
In a way, yes. It's meant to provoke discussion about the future, about human optionality and our possibility space over these really long timescales. And the foundation does more than just the clock, right? They have seminar series, linguistic preservation projects.
That cool steampunk bar in San Francisco, The Interval.
Right. And even a platform for making long-term predictions or bets on future events. It's a whole ecosystem of long-term thinking initiatives.
It's interesting to compare it to something like Stonehenge.
That's a great comparison. Both are sort of monumental timepieces, in a way. Both are designed for astronomical alignment. Stonehenge with the solstices, the clock syncs with the sun at solar noon.
And both could serve as reminders, across generations, of our connection to cosmic cycles.
Exactly. But as you know, interpretations change dramatically over time.
Oh, absolutely. Stonehenge has been called everything from a huge dumb heap in the 16th century
Right.
to something linked to Solomon's Temple by Isaac Newton, or even Satan's work by William Blake.
And now it's a UNESCO World Heritage Site.
So the meaning isn't fixed. The clock's future meaning is also open-ended, as one writer put it.
Right.
It'll always need that interpretive asterisk depending on the era.
Which really highlights what the author called tempocentrism.
Tempocentrism.
Yeah, the pathology of being excessively centered in one's own time frame. Our tendency to view everything through the lens of our own short lifespan and immediate concerns.
That makes sense. We struggle to think beyond our own lives, let alone millennia. So how can this kind of thinking, grappling with deep time, actually help us? It feels like it could be paralyzing thinking how small we are.
It could feel that way, but it can also be incredibly grounding. There's a thinker, Thomas Berry, who focused on even deeper time, the whole 13.7 billion years since the Big Bang. And what's fascinating about Barry's perspective is his idea that human history isn't just some random accident or even the peak of cosmic evolution,
Huh.
but rather another manifestation of the same fundamental energies that shaped the universe from the start. He had this profound idea that through us, the universe holds a way to see, feel, and ponder itself.
Wow. So instead of being insignificant specks, we're actually the universe becoming self-aware.
That's one way to interpret it. It offers this deep connection, a sense of strength and an underlying peace, as one source describes it. It connects you right back to the planet's molecules, the ancient forces, standing on layers of rock, realizing you're made of the same stuff, part of the same ongoing process.
That's a powerful perspective.
It is. But it also throws the challenges into sharp relief, doesn't it? Especially when you consider the short-termism that drives so much of our current world, particularly in the tech industry, that funds things like the clock.
Right, the irony that critics point out. Rapid consumer cycles, the gig economy.
Exactly. And the connections some funders have to industries perpetuating short-term problems, like fossil fuels, Shell, for instance, being a major global carbon emitter.
It's complex. The funding comes from systems that often seem at odds with the long-term message.
It's definitely complex, and our aim here isn't to take sides, but just to understand these, well, often contradictory connections.
Yeah.
The Long Now community itself reflects this ambiguity. It draws from cybernetics, from ideas like eco-modernism, the belief that technology can solve environmental problems.
Even from defense contracting backgrounds, right?
Yes. It's described as this ambiguous but also remarkably generative mix. You find stunning brilliance alongside fringe speculation. You see brash countercultural idealism working with or funded by some of society's biggest power structures.
It's a strange mix, but maybe a necessary one.
Perhaps, thinking about deep time, engaging with projects like the clock, maybe it can spark what one source calls unhinged creativity and unapologetic eco-pragmatism. It might push us towards bolder ideas for tackling the huge challenges we face: climate change, nuclear risks, deep social divisions.
So embracing that long view might unlock new ways of thinking about the present.
That seems to be the hope. Ultimately, thinking about deep time, it helps us see our lives, even our whole civilization, as maybe just a glinting mote on a rock face of the future, but also shows us how deeply connected we are to this vast ongoing story.
Yeah, it forces us to reckon with a universe that just keeps getting bigger and more complex the more we learn about it. Whether we're looking down at ancient rocks or up at images from the Webb telescope, it's a constant reminder that this moment right now is just one tiny frame in an epic movie.
It really is. And that leaves us, and you, with a final thought to chew on. If we accept that we're just a brief flicker, and that even advanced civilizations might leave only the faintest traces behind, what single message or what artifact do you think our civilization should try its absolute hardest to leave for a truly distant future? Knowing that geology and time will do everything they can to erase it, what's the one thing worth preserving against those immense odds?